Uh, Good morning. I'd like to introduce you to the AMTEC Advanced Manufacturing System Simulator. My name is Keller McGaffey. This is Kelly Lowry. Between us, we'll be kind of talking about the sequence of operation. I'll start off by pointing out all of the subsystems around the AMTEC simulator, and then Kelly will get into some of the control items specifically in the main panel over here, as well as some of the controls devices. So in the meantime, Kelly is going to be running some parts down the line there he is. So to initiate the cycle, you have a cycle switch here that has a green light indicating that it's okay to load a part. And to initiate the cycle, like you saw Kelly do, you simply place your finger on the switch here. So at this point, we have a green light, we can load another part. The other feature that we have here is a safety light screen that if at the wrong time in the cycle, if you put your hand through, will cause the system to e-stop. There's a lot of safety devices built into this machine, all industrial components, incidentally. Alongside the conveyor here, we have a pull cord, which is very common in industry, especially along a long conveyor. Pulling the cord breaks the switch here, and then causing the machine to go into a fault condition. We have basically four components here. We have a load conveyor that goes into a robotic corner. The robot corner, we have a fault. The robot sits in its own module. This breaks into four components here with about 10 screws. So the load conveyor separates from the robot stand and separates from the unload conveyor. And then our fourth panel is the control panel over here. So if we kind of walk around the machine here, I think I'll start pointing out some of the components here. We've got all safety interlock doors. It happens to be held down by gravity. Others are opened with a latch assembly. But they're all interconnected here back to a safety circuit that Kelly will show inside the cabinet. But anytime you open a door, it causes an e-stop condition, which is an industry standard. The load conveyor is powered by a variable frequency drive. And the other conveyor is powered by hydraulics. So we're mixing all kinds of different subsystems into the equation here. So variable frequency drive. If you come around a little bit further here, you'll see that we have the Trabon automatic lube system. And this is a fully functional lube system, even though the unit itself requires no lubrication. Everything is sealed for life bearings. We have simulated a real-world Trabon lube unit. The only difference is that it pumps simply back into the reservoir as opposed to being distributed throughout the machine. And we did that for cleanliness, so we're not dripping oil all over the floor in the schools, that kind of thing. But anyway, fully functional. You'll notice, and Kelly will get into more details here, all the junction boxes here, all of the remote I/O, everything has been done in a variety of different manners so that the student doesn't see a one type of wiring approach, but actually sees all different kinds. And everything is plug-in so that the teacher has the opportunity to loosen connections, which is real-world troubleshooting, to simulate faults, and the student has the opportunity to go in and troubleshoot. Moving around, we're now at the robot station, and this is a fully functional industry, very small. It's the smallest robot Fanuc makes. And the purpose of the Fanuc is to take the pallet from the load conveyor to the unload conveyor. And the Fanuc controller here, which is equipped with an e-stop button, industry standard, as well as this lockout tagout here, which I wanted to point out. You'll see on the main panel there is the OSHA approved safety lockout tagout sign. And the main power is obviously at that panel, but there is a secondary lockout, which you'll see here, as well as on the pneumatic and the hydraulic. And those will be identified by these stop sign type tags. Also, as part of the Fanuc Robot is the teach pendant. And this is used in manual mode to program the robot. So students will have a real-world Fanuc teach pendant to reprogram the robot's path. In industry, oftentimes we're looking to cut cycle times down, so this would be a great exercise for a student to work on making the robot faster in its cycle. The robot End Effector is equipped with spring-loaded vacuum cups, and that picks up the pallet and then moves it onto the next conveyor. There's also all kinds of part present switches here that we built into the unit. We have standard photo eye, we've got laser, we've got photo reflector, trying to think, induction proximity switches. So all different kinds of switches that students will be exposed to. In this corner, as the robot is cycling, in the real world, robots sometimes fail, they go down. So we built a bypass, which is this device right here, that in the case the robot goes down, and we'll demonstrate that in a second here, there is a servo pusher that will move the pallet from the load conveyor to the unload conveyor. So we built in a servo unit here, so there's exposure now not only to an AC drive on the variable frequency drive on the load conveyor, but also a DC servo here. There's a belt driven, so there's belt and pulley arrangements in here as well that the student can get into. Kelly, why don't we go into bypass? So what we're going to do is bypass the robot. So the robot now is no longer working, and you can see the DC servo moving this carriage back and forth, and mounted to the carriage are two fingers which are recessed in the side guide just below the robot. And as the part comes in and the part present detects the part, the servo fingers then will push the part onto the unload conveyor, bypassing the robot. Okay? Hey, while you've got that, I'm going to demonstrate something here too. The other thing that we did here, there's all kinds of ways to cause faults in this unit, almost an infinite number of ways. Some of them are electrical, some are software, but we also have some mechanical opportunities here, if you will, to create a fault that's not really very, it's kind of hidden from the student's eye. And that is these loose screws, which can be put into a different location, causing a mechanical fault with the servo. So the servo will actually bump into the screw and fault out. Not obvious when you look at it. Okay, so we have that not only here, but we also have it on the unload end for the pneumatic pusher, which I'll get to in a second here. So we've taken a look at the servo bypass and the mechanical interference. Now we're moving to the unload conveyor here. Now the unload conveyor is different in that it's driven by a hydraulic motor. So what you'll see here mounted underneath is the hydraulic power unit, and it's industrial, so very real world with sight gauges, pump motor, filters, everything that you would expect to see on a hydraulic power unit. And it powers this hydraulic motor here. And not to repeat too many times, that the variable frequency drives on the load conveyor, the unload conveyor has hydraulics. The hydraulic motor and the VFD both incidentally go through a chain sprocket up to the conveyor. So there's two opportunities to train on alignments, sprockets, chains, that kind of thing. We have another I/O box here. I didn't point out this device on the other side because it was kind of hard to see, but on the load conveyor and the unload conveyor, we have these pneumatic rod cylinder stops that act as sort of an escapement. So if the part comes into this corner station and another part is coming behind it, this separates the two so that they're not rubbing against each other. That's very common in industry on conveyor systems called stops or escapements. So you have a rotted cylinder here. When we come around this side of the unload conveyor, as the part comes into the corner, you'll note that the pallets have a tag on the corner here, and that tag is metal. This switch in the corner here reads only metal, so we've also created a couple of pallets that have plastic tags. So if that comes into the corner, the pallet will just simply stay in the corner because it will not be read by this switch. It's another troubleshooting fault scenario. And they look very much alike. So it's not very obvious to the student. So once we come into the corner, now to release the part, we have a a pneumatic pusher here, and this is a rodless pneumatic cylinder. And it also has the two fingers that are buried inside of the side guide, and that's what's used to push the pallet off into the unload chute. The other thing that we built into the unit here is an industrial components pneumatic stand here. And we've got the safety lockout here with the pneumatic lockout tag saying that is the pneumatic lockout. We've got drip legs, valves, gauges, everything that is real world in industrial type environment for a pneumatic stand, and that's typically what they look like. Incidentally, we have two power feeds into this unit here. The first is off the corner there. That's a pneumatic drop, which comes over into this input right here, and that's just plant air. The other is when we get to the control panel, there's a 480 volt drop into the main panel. That's the only two power sources required for this. When we talk about this unit overall, it's designed to be very modular and movable. You'll notice that every leg has a pivoting roller assembly, so this whole thing can be easily repositioned, including the main controller, which also has rollers. This breaks into 4 modules. The control panel is one. The unload conveyor gets unbolted basically along this brake line here with a couple of bolts. It pulls away. The robot is in its own module, a couple of bolts, that pulls away. So it breaks into 3 modules for easy transport and easy moving around in the community college environment. I'm trying to think what else here. This, from a safety standpoint here, we've designed this so that there is no access for anybody to get their hands into anywhere, including on the top, where you could reach a pinch point or some kind of compromise your safety. And so it's very visual with the plexiglass guarding, but it's also very contained, so there's no way somebody can get in and get hurt. Just like we had on the servo drive, and incidentally that was a demonstration here of another Estop. We have the gate interlock here. When I open the gate, the equipment Estop. But we have mechanical interference devices, just like we saw on the DC servo, that by just simply moving these screws and placing them, we cause a mechanical interference, causing another fault scenario. We're now at the unload side of the conveyor here. We have our storage unit for the pallets as they come off. This is fully enclosed guarding so that you can't reach up and in. We got another photo eye here that detects that there is a part in the storage area. And then from the last physical safety component we have is on the floor here, which is an industry safety mat, typically used around a robot cell so that when a person stands on the safety mat, the robot doesn't move, so there can't be any interaction between a human and a robot. In our case here, when we stand on the safety mat, the part will not come into the unload chute. So that's how the sequence is designed for the for the safety mat. And then the last component we have here is the control panel here, the main controller. And just a couple of overview things here, and then Kelly will get into the inner workings of this machine. But here we have our main safety lockout sign, which is designed, again, to OSHA standards here, indicating where the lockout points are on the physical machine, the procedure for locking them out and releasing energy, and then the way to verify that the procedures are locked out. That's very typical and actually mandatory on any production equipment anywhere in the industrial environment. These tags here indicate that this is your main electrical and hydraulic lockout, so if I lock that out, there is no power to the machine. Then over on this door here we have the human-machine interface, or what we call the HMI panel. Kelly will demonstrate this, but this is the sort of the way the human being interacts with the running of this machine here. So you've got all kinds of touch buttons on here, as well as some hard buttons and your emergency stop. On the top of the panel we have our stack light, which indicates green, yellow, red, whether everything's okay or we're in a fault scenario or an e-stop scenario. And there's a radio frequency antenna here, which Kelly will get into in a minute. And so that's the overview of the Advanced Manufacturing Systems Trainer.
As Keller's pointed out, this is the HMI, the human machine interface, to run the machine. I want to point out that there are 3 user buttons here on the side. They're set up to be done in the field, to be programmed, to be wired. The top user button here, user 1, is already wired to an input and output. User 2 has wiring going to a terminal and stopping dead. It requires some more figuring it out from the drawings. User 3 has the wires pulled, but they're not connected on either end. When we open the door, you will see the different connections. Across the bottom here, we have the main power on, master on. We have an auto manual selector switch. We have a continuous auto cycle. We have a fault reset hard push button. We have a robot enable or robot bypass selector switch to go between the robot or the servo pusher. A lamp test button to light up stuff like a Christmas tree. On the main screen, it boots up here. You'll come up with a picture. You'll just touch it. You'll notice across the red across the bottom is a scrolling fault message. You go to machine condition, and it tells you the status of what's happening on devices on the machine. And if you'll note here, there's some with device tags that have the identifiers that are in the schematics. You can go to different pages of statuses, and they do not have those device tags. So the HMI screen has been programmed in such that it has a variety of indication. Some are the real device, some are dwells from the program, some are internals, not real world. And they're all mixed on the screen. You would go to the manual function screen. You have the ability to change the speeds of the conveyor. You have the ability to operate everything manually as well, to start and stop, with no indication of how it sequences on purpose, but it does flow from left to right as you read a book. The fault page will go through and give you a history of what kind of faults have occurred and when they've been cleared, so you can come up and see what has happened. The robot status to show the I/O going back and forth between the robot and the main PLC. And as I pointed out here, those user buttons are wired, and the third one is not, and there's spare wires down here so people can learn how to wire back and forth. In general, on the main panel here, you got your main disconnect. You have a distribution block. You got some 480 up on the top here with motor circuit protectors, a motor starter, contactors. You have 120, and the rest of the machine is basically 24 volts DC. A main power supply, a wireless RF unit to work with a fault-induced remote control that you will carry around with you as an instructor in trip faults. Fuse protection, a servo drive, as well as a variable frequency drive. And then you go down to the main plate right here. This is the Allen Bradley Compact Logix PLC plate that happens to run this machine. This plate is interchangeable. It's got main the PLC with built-in I/O, as well as point I/O by Allen Bradley. So you can see Allen Bradley's structure of addressing, as well as a communication media. This one happens to be picked with Ethernet to talk to here, and you can see addressing of the specific brand. The cables come across to these plugs, which are removable, and they're all screw terminals, so that you can, as a trainer, can come in and unscrew, move wires to the wrong location. You can do it with the built-in wiring, or you can just unsnap these and remove the plate and potentially change to another brand, Siemens, Modicon, Telemecanique, whatever, to operate it. The I/O was picked here with analog. So there's analog 4 to 20, there's 0 to 10 volts, discrete ins and outs, so that it's a standard one. Almost every brand has all those specific type of boards. So from here, the wiring comes across and hits this terminal bank. They have jumpers in here. The jumpers are done in 3 different ways in this panel. There is a jumper with a built-in one that comes as with a terminal strip, standard. There are jumpers that are behind wires, and there's also wire jumpers going between terminals. They're all mixed. The wiring has a variety as well. You have colored wire, we have THHN, we have MTW wire, we also have color-coded wire, we have cables with numbers on them. So there's a variety through the entire machine assembly system here that has different brands, it's all different. So you can see a variety. The wiring is also done, besides the wire jumpers, it's also done different. If you get in a habit of going from here to here as you're troubleshooting, you're eventually going to find some that don't go here anymore. They've been moved in the panel on purpose to get rid of the ruddy routine from the people when they're troubleshooting. So as we come down, we go to the 24-volt power source. Actually, all the breakers from the power. Ethernet switch. This here is a safety controller by Telemecanique. It basically operates and monitors all of the safety circuits that are on board the system, light curtains, safety gates, e-stops, pull cords. They're all running through here. This then operates safety relays, a CRM relay and an output power relay for the machine. This is programmable, these are not. We have connections that go out in cables, these cables down here that go out to the point I/O junction boxes out in the field. This is internal terminal relays that are purposely removable, and they're unlabeled so that you can't see what they are. So you can cut pins off on them and stick them in and have problems. They don't have an indicator light if they've actually worked. There's only an indicator light that the coil has been fired from the PLC. And there's a couple different types of relays that are used in here, and I'd like to show you where the other style is used right here on this panel. So if you come down here and look, there's a plug-in cube relay, and I'm going to pull it out. You can see, plug-in cube, different style, just to show people, and it's got a mechanical flip and an actuator on it. They also have jumpers on here that are put on the back. You can't see them, but they're down inside, buried on these terminal relays. And those jumpers are, I'm trying to think of the right way to say it, but those terminal relays have jumpers on them, and those jumpers are making the relay run backwards. Some of them are in reverse. So by habit of knowing, 11, 14, 12, the contacts and the coils going through them, they're not all wired that way. So some of them have jumpers and inverted the signal going the wrong direction. It's very low voltage, very low current, so it's purposely done for troubleshooting. You got to follow the drawings. The cabling goes out the bottom through the slots. We have a cooling fan that runs through it. We do have a light in here in this case, it happens to be movable, so that you can light it up. And going back to the fault relay board, you can see that if you press a fault, it lights up in here. I don't know if you can see that. Okay, so anyhow, press it, it holds the fault until you press it again. So you can have this in your pocket or whatever. You can walk around, trip the condition. There currently is 14 of them programmed with the remote. but basically kind of unlimited on the maximum quantity because we can index them from the HMI. Okay, and on the back of the machine here we have lockable disconnects that have quick connect plugs on them, and those plugs go out to the VFD motor, the hydraulic motor, and robot power. And if you look right here, you can see they're color coded as well as keyed so that you can't get the power sources wrong out into the field and destroy something. And they are lockable, so we can turn it off and put a padlock in here and lock it out, and you can also remove them. And you can see that they got keyway and different pin power. And you cannot turn on, with this removed, you can't turn the disconnect on, will not work. Okay, this is the point IO remote IO boxes that are used out on the machine. And in the machine here they're labeled, like this one happens to be the load junction box enclosure. And if you notice on the top, there are connectors and an industrial Ethernet connector as well to bring the communication in. We have 24-volt identification on the junction box, hazardous signal, and a warning. Then we'll open it up, and we'll open it up. And you're going to notice in here the I/O blocks, communication I/O blocks. There's Ethernet in here, as well as digital in and digital out modules here. You'll notice that there are different types of terminals down below here, black ones that are multicolored. Those happen to be double deck jumpered ones as well, built in. And there's also terminal relays in here as well. You notice multicolor wiring. This is the main cable plug that comes in to run the whole junction box. You can see it coming in right here, plugs right in.